Okay, so in this video we'll be discussing about case 2 of tension. We were done with the case number 1. So in case number 2, that is that when one body move vertically and other body horizontally. And as you guys all know that in case number 1 they the line was that when one body move vertically and another body also move in vertically, but here you can see that one body is vertically and second one is horizontally. So just imagine that there are two bodies, or consider as the two bodies A and B having a mass, okay, m1 and m2. Let me discuss first of all. Okay, here this is a table, okay. Here this is a body B, and here is a frictionless pulley. As you can see that in that case number 1 that was also there, and this is body number A. This is mass 1, no, this is mass 1 and this is mass 2. So we are having two bodies A and B on a table, M1 body A, M2 body B. And you can see that M1 body having a more mass than MB. So we can write here that M1 body having a more mass than M2. That is, as you guys all know, that is connected with the string. That is a string, okay, that is passing over the frictionless pulley. This is a frictionless pulley. So we can write about body A and body B. Okay, so about body A, we can write that the weight of the body A is downward, as you can see, and the weight, and you can say that tension. What was the tension? Tension was that a force that is extending on a body. Okay, so here you can see that the weight of a body is downward and the extension of a force on a body is upward. So tension is upward. If you're talking about the net force, so here you can see that here you can see that weight is more and tension is less here. So we can write that W minus T. Okay, and here you can see that here is the force. So having a force is having a formula that is F is equal to ma. So we can write here easily that ma1 is equal to, here W is equal to mg. So we can write here that m1g, because mass number 1, and this is body A, this is body 1, this is also body 1, and these are the formula minus T. This is equation number 1. Now you can see that the weight here, first of all let's talk about, this is m2 mass. Okay, if you're talking about the weight, so weight of the body B is downward and tension towards the frictionless pulley, that is, you can say that that is toward the pulley. Tension if the body B is toward the pulley. And if you're talking about the normal reaction, that, as you guys all know, that there were a third law that every action has an opposite reaction. So here you can see that there is an action on a body, so there will be an opposite reaction too. So we can write here the normal reaction. Here you can see that the weight of a body B is downward, and if you're talking about the normal reaction, that is upward. And we can write here that about the tension, that is toward pulley, tension toward pulley. Okay, so here you can see that we can write that too. If you're talking about the net force, so net force, here you can see that every action is an opposite reaction. So, and you can see that normal reaction and weight are equal here, because the weight the body is having and the same reaction body B is having. So this will be getting cancelled because they are equal. So remaining one is the tension. So we can write here the net force is equal to tension just, and we can write net force as force is equal to ma, and we are talking about body B, so we can write here m2a and t, that is equation number 2 and that is equation number 1. Okay, because you can see that in there the normal reaction weight got cancelled and tension got remain. So the next we are having to find the values of acceleration, to find the values of acceleration. So as you guys want to find the acceleration, we will be adding the two equation, that is 1 and 2. Here you can see that number 1 equation was there, that as you can see that there is a rule that left hand side will be added by left hand side and right side will be the added by the right side. So here you can see that we are having a m1a here, and here you can see that m2a is there. So I write here m1a plus m2a, and about the right side equation there is m1g minus t and plus t. Okay, here you can see that m1g minus t and plus t, this is that. Okay, so here you can see that from both of them the common is a m1 plus m2, and here you can see that positive t or negative t will be cut it down and m1g got remain, and we can write here that m1, okay, we can write here that m1 upon m1 plus m2 multiplied by g. Okay, m1 multiplied by g and m1 plus m2 here. So acceleration is equal to m1 upon m1 plus m2 multiplied by g. Okay, so as you can see that to find the acceleration, the formula is this. To find the tension, the main is tension to find. So to find the tension, we will be dividing both equation. Okay, so here you can see that m1a upon m2a left hand side, m1g minus t upon t right hand side. Okay, these were the both equation. A will be getting cancelled by a. Here the m1 upon m2 can remain, and you can say that m1g minus t upon t. Here we can cross multiply by them, and you can see that m1 will get multiplied by t is equal to m2 will get multiplied by m1g minus t here. Okay, so here I can write that m1 will multiply by t, it will get m1t, m2 will multiply by m1g, that will be m1 m2g, and if m2 will multiply by t, that will, here we are having a plus, here we are negative, the plus minus minus, m2 will get multiplied by t, so there is the m2t. Okay, so here you can write that here it is getting positive, it will be moving here, it will be getting, here it is negative, it will be moving there side, it will get positive. So m1t plus m2t is equal to m1 m2g. Okay, so here you can see the common on both of them is t, so m1 plus m2 is equal to m1 m2g. We can write that as a t is equal to m1 plus m2 multiplied by g. Okay, not plus. T is equal to this whole value and m1 plus m2. This is the formula of the tension in case number 2. Okay, so as you can see that the in this equation of the acceleration there is no tension, and here you can see that in tension there is no acceleration. Okay, so in both of cases this is same, that in acceleration the tension is not there, in tension the acceleration is not there. So as you can see that when one body is coming downward with the same acceleration, okay, and second body is moving upward with the same acceleration, and you can see that there is a balance, that one body has having a more weight and second one is having a less weight. Or if you're talking about tension, so one body is having a tension downward, second body is having a tension upward. Okay, so it will got balance. So this is about the case number 2 of tension.